This conference will now be recorded.
Vinay, you also come for Python classes tomorrow onwards. Who are not attended the Python modules previously, just come for 7 p.m. as well.
Okay, sir.
Okay. Let's wait for 2 more minutes. People will join the session. Okay, so let's just start for today's class. Today's class is from the supervised machine learning algorithm. I would like to go for complete the simple linear regression. I was trying to complete it, but if I'm not, no worry, we'll finish it. Just a minute. Okay. Yes, fine. So guys, noted the new concept, which is the simple linear regression, or you can say that it's a linear regression. First, we'll try to understand the simple linear regression. Simple linear regression. Okay. So let's go for understand what exactly the simple linear regression. Yeah. So when come to the simple linear regression, okay, see what you know about linear regression. First of all, what you know about linear regression? See, I have a data. So data means what? It's some information, right? It's some information. I have some data. I have some input data and I have some output data. Let me consider this is my input data and this is my output data. So for each and every input, for example, 1 and 2 and 3 and 4, this is my input data. Okay. And the corresponding output data is, for example, 2, this is 4, this is 6, and for example, this could be 8. Okay, this could be 8, right? This could be 8, right? Okay. Okay, so in this particular situation, let me draw a small diagram. This is my X is my input variable, and this could be my output variable. Okay, this could be my input variable and this could be my output variable. In this particular situation, what happened we'll see. So this is my 0, this is my 1, and this is my 1, this is 2, and this, for example, 4, 1, 2, 3, and this is 4. Okay, and this could be, for example, 2, 4, and 6, and this is 8, right? In this particular situation, you just draw the each and every point. When my X, what will be my Y? It's a 2, right? Then you can just drop this particular point, and here you can draw this particular point, and here you can draw this particular point, and here you can draw this particular point. When you join this 3, when you join this 4, okay, so this is the line we are calling it's a fitted line or regression line. What it is? A regression line. See, this is the line we are calling it's a regression line, but here this is the line which is try to pass with all points, which is try to pass with all maximum points. This is what it's a regression line. Okay, here the data will be very sweet, so that it's a you got an output in a perfect manner, right? But for example, when the data will be not something like this, here the data will be like it's a very standard structural format is there, so you are getting this particular line. Okay, but now what happens if I have a data something like this? I have a some X and Y, and you have some huge data. You have some huge data, and there is no much relation actually. This is 1, 2, and 3, 4, 5, 6, 7, and 8. Okay, for example, this is 9, this is 10, again 8, 20, 30, 40, something like this. Okay, there is no some it's not exactly the linear. Okay, it's some data which is something like this. In this particular situation, I can draw these particular points. When I draw this corresponding X and Y on the plot, when I draw it, then what happened we'll see. This is my point 1, maybe somewhere else is something like this, maybe something like this. Okay, maybe points are something looks like this, not exactly the line format. Okay, in this particular situation, you have to you have to find the best fit line. You have to find the best fit regression line. See, how can I decide it in this particular situation? Maybe the line with something goes like this. Okay, maybe the line something like this, maybe the line something like this. So lot of lines you can draw on the plane. Lot of lines you can draw on the plane. Yes or no? See, but I wanted the best fit line. I want the best fit line. How should I draw the best fit line? That's a question in this particular linear regression. Maybe this one, maybe this one, maybe this one, maybe this one. You have a lot of lines, lot of regression lines. From this all multiple linear regression lines, which is the best one? Which is the best line that you need to figure out it, that we need to be find out it with the help of this particular concept. Is it clear? Is it clear or not?
Yes.
Yeah, yes, sir.
Okay. Okay, how you can able to do it, this one we will understood of this particular session itself. Okay, so concentrate on, guys, please make sure that concentrate on this one. See, for this one we are using the linear regression. Maybe you have the only one input variable, one output variable, right? Maybe if I have the multiple input variables, here I have the x1, here x2, and for example this is my y. In this particular situation you have to draw, right? But it could be 3D line. If it is a 3D line only, we can able to draw it, we can able to see the graph. Okay, maybe if I have the more number of inputs, maybe x3, if you're increasing the number of inputs, then it could be very, it could not possible to make it the graph, right? Okay, but even though you have to be find out the best fit line. Okay, for that one, irrespective of the simple linear regression or irrespective of the multiple linear regression, you should go with this particular concept only. Let me consider I don't have this many inputs, I have only one input. Let me consider in such a way, I have only one output variable and I have the only one input variable. In this particular situation, my best fit line, you will try to understood now, my y hat in the sense it's your predicted variable. Okay, my line, so b naught plus b1 into x. Okay, when I have only one input variable. If I have the multiple input variable, then what happens? If you are increasing the multiple inputs, if you are increasing the multiple input size, then my y hat, it could be increases something like this: b naught plus b1 x1 plus b2 x2 and so on. Okay, and so on. If we have the n number of inputs are there, then we have the n coefficients. This is what when we have the multiple linear regression. This is the formula for the multiple linear regression. Multiple linear regression. This is simple linear regression. You might be thinking where this y b naught, where this b1 is coming, why these coefficients are coming. Okay, for understanding this one, what you will do now, we can see my first thing. When we see this particular regression line, see this is the line. If I extend this one, which is passing through the 0 or not, that means it's an intercept point. And you can take the any 2 points, change in slope. Okay, you can take the any 2 points and we have to find the slope of it. You can take the any 2 points in this particular line, you can find the slope. See, this is the slope, you can say that it's a b1, and this is the intercept, right? This is intercept. The intercept we are calling it say b naught. Okay, that means if you want to find out this particular line, that means we need to calculate this particular coefficients. Our aim is that we need to find out the b naught and b1. If and only if we know this particular b naught and b1, if and only if we know this particular b1 and b naught, okay, then only we can able to find out this particular best fit regression line. Tell me, guys, what is our aim now? We have to calculate this particular b naught and b1. Yes or no? Yes or no?
Yes, sir.
See, even it is the simple linear regression, even it is the multiple linear regression, okay, you have to find out this particular coefficients only. We should go for find out this particular coefficients. That's it. Okay. Yeah. So usually in other textbooks or in different situations, this y hat, we can say that it's a hypothesis, h theta of x. When usually if I'm using this particular formula, y hat, then usually we can use the b naught, beta naught, b1 of x. But when I using the h theta of hypothesis, then usually we can use theta naught plus theta 1 of x. That's it. Okay. So this is the formulas will be same. Even you can use the either y hat, either you can use the h theta of x. Okay. Okay. Yes or no? Now,
Yes, sir.
let me consider this is my formula h theta of x equal to theta naught plus theta 1 of x, and you know how this will works. I can tell you. How, my intention is that you can say that it's a beta naught, you can say that it's a beta 1. Okay. Our aim is that you need to find out this one. Okay. See, first initially you have to consider, you have to be, so this is my data, this is my data. Okay. So initially I can let consider, so the algorithm how it works I can tell you. Let consider some random beta naught and b1. With help of this one we can able to find out this particular line. Okay. The reason initially you are selecting some random values. Initially I just selected a small random values. After you selected this particular random values, I just draw the line, and with this particular line, whether it is the best fit line or not, how can you know that? When my loss is less, when loss, that means error is less, when loss or error is less, then that particular values are best values, best coefficients. Okay. So first initially I can able to consider this some random beta naught and beta 1. I can draw the line, and after that one I can able to find the loss function. My first step is step number 1. My first step is what? How this works I can tell you. Consider beta naught and beta 1 random values. Okay. Then find the regression line. Okay. After that one, find the loss. Okay. And find the loss. Okay. After you find the loss, then my next step is update this beta naught and beta 1 values. After updating these values, again we can go for the second step, and again go for the third, again go for the fourth, and so on. Again, after updating the beta naught values and beta 1 value, after you find the loss, we need to update it. After you updating this one, again we need to go for the find the regression line. After you find the regression line, new regression line, then you can able to find the loss. After you find the loss, then you can try to update the beta naught values and beta 1 values. This is keep on going it until unless when? Until unless my loss is, in 2 steps this particular loop can be dropped. One is the loss is 0, or my beta naught and beta 1 values are not updated. Values are not changing. Whenever the beta naught values and beta 1 values are not changing, that particular situation, so your loop can be stopped. Okay. Now you understood how this particular linear regression can works. This is the algorithm, guys, nothing else. How this particular algorithm is working. First, initially we need to consider the beta naught values and beta 1 values. Then after, you're finding the regression line. Then you're finding the loss. And then after, you're updating the beta naught values. After updating with updated values, again you can able to go for plot the regression line. And with that particular regression line, we can able to go for the loss. And then after, you can updating this particular values. Okay. In this particular situation, if I plot this particular loss for every beta naught values and beta 1 values, for every beta naught values and beta 1 values, if I plot this particular loss, then how it is looks like, let me consider this is my beta values. Okay. And this is my loss. So when you, with respect of the beta values, we have to plot the, you have to plot the loss. That situation, if I may get the loss function or gradient distance is something looks like. So this is what gradient distance. If I plot the loss versus beta values, okay, then you may get this particular parabola. This parabola we are calling it say gradient descent. Okay. Is it clear? Is it clear or not?
Yes, sir.
So this is
Yeah,
the
yes, sir.
you need to remember, guys. Mainly the simple linear regression or multiple linear regression will works with this particular formula. Initially, we are going to be considering the beta naught values and beta 1 values. After that one, we need to find out the regression line, and then after, okay, then after you are finding the loss. If you find the loss, then what you will do now? Okay, you have to plot the loss value with respect to the beta values. After that one, we will try to updating that beta naught values and beta 1 values or beta values, usually coefficient values. You have to go with this particular regression. Okay, this is fine. What is the loss function? It's the error, right? What is my loss function? What is my loss formula? So this is the loss formula. It could be constant. So I'm just writing that particular formulas. And initially beta values I can consider, right? So beta naught and beta 1 of x initially, this is my first step, initial values. I can consider this is my initial values, right? After that one, what I will do, I can able to find out my loss function. My loss function is 1 by 2m. Okay, 1 by 2m sum of y hat of I minus my y values. Okay, original value, predicted values minus the actual values whole square. Okay, if you go with this particular formula, this is my predicted, each and every predicted. So initially we have the y values and x values, right? Initially we have the y values and x values, and for each and every x value and corresponding beta values and beta values, I can find out the y hat. Okay, and this particular y hat and this particular y values, each and everything we can able to subtract, and then we can do the square and sum of it, and finally how many number of records we have it, that is your m or n, whatever it is. You can consider it is the n or m. Okay. If you go for apply this one, you will be getting some value, some constant. You will be getting some value. This is the value, is your loss value. This is your loss value. Okay. So after you are finding this particular loss value, you would like to go for plot this particular loss. Then after you would like to updating the beta values, right? That updating the theta values, we are calling it a conversion theorem. So updating the beta values and beta naught values, we are calling it a conversion theorem. Conversion theorem or conversion algorithm. When you go with the conversion algorithm, so this particular values, or it could be, this is my, you can say that it's a theta or you can say that it's a beta, right? So let me consider this is my beta. So beta of j is to equal to my previous one. Okay. And then after you have to do it somewhat derivative. Slope of it. Okay. Alpha is my learning rate. This is my constant. See how speed you are going to be conversing, which is deciding by this particular alpha. This is my learning rate into derivative of your j beta naught beta 1 of your beta j. Okay, your j will be, it's a 0 or it can be 1, it can be 2, it can be anything. Okay, so my old one, this is my old value, this is my old beta value, minus alpha is my learning rate. It could be constant, usually we are considering it the 0.01 into, so when we have a one particular value, loss value, if I find the derivative for this one, you might be getting some constant. Okay, it could be very less. Okay, it could be very less, small value, for example some small value we are getting. So old minus 0.01 into some small, that means what, your beta values can be reduced or not, or it can be increased or not. See, if my loss is increases, if my loss, so this, if you find out this beta values and everything, then this, with help of this particular beta values only, you would like to go for updating into this particular y hat, then go with loss function, then go with conversion theorem. So this is keep on doing it until unless it will be go for conversing into, it will be go for conversing into smaller value. Okay, this is the algorithm actually. This is exactly the algorithm, guys. Nothing else. This is the exactly algorithm is working behind the simple linear regression or multiple linear regression. This is what, this is the exactly the machine learning, a simple linear regression is working. So here there gradient descent we covered, and conversion theorem will help you to updating the beta values or theta values. Loss function will help you to find the, okay, error. Okay, so this is what the basic algorithm, guys. I don't want to brush up much more information, you just keep learning this one. By tomorrow what we will do now, we will do some kind of parameters. Before the parameters, I can give you some beautiful example with a practically. Okay, I will take some I will take some real data and I can able to update it. I can find these particular beta values and beta 1 values, and meanwhile the gradient distance also I can able to plot it. After that one, whether my model is good or bad, those are the parameters, those are matrices are there, those we will talk by next class. Okay, tomorrow we will see somewhat practical information. Don't misunderstanding something like this, the class should be half an hour. So the reason is that if you're missing any single point, it could be lost for you. So practice or understand what is conversion theorem, what is loss function, okay, and what is linear regression. So you can go through this particular class. Tomorrow we will see practical, then after we can able to apply somewhat matrices, and after that one again with help of that particular matrices what we did in tomorrow's project, and we will conclude that particular project. Okay, this is my plan. That's okay. And I hope you guys are good. Then we'll catch up by tomorrow's class, guys.